All right, on this page, we're going to talk about collision points and intersection points for parametric. And one of the nice things about parametrics is if we have like two airplanes, and there's an airplane, and here's an airplane, okay, and they're flying around, and this airplane flies, and then this airplane flies, their paths can cross without the airplanes actually colliding in the air, which, is a good thing, because airplanes colliding would be very, very bad. So what we want to talk about is the difference between where paths cross and where things actually collide, and parametrics make that actually pretty easy. So let's do this with ghosts here. So suppose two ghosts are moving in a room and their paths can be modeled by x1 equals 2t, y1 equals 4t minus t squared, and x2 and y2 are modeled by those two things. When and where do the two ghosts pass through each other, and when will their paths intersect without them actually occupying the same space? So I use ghosts so they can pass through each other yet keep moving. So if we want to figure out when this happens, what we want to know is where do they collide and where do their paths cross? And we can do that on the calculator by going into y equals, switching my mode to parametric first, pardon me. Going into y equals and putting the paths of the ghosts in x1, y1, x2, and y2, just like I have there. So take a second on your own, put those into your calculator. All right. And then I am going to go to Zoom 6, which is a standard zooming window. It's a great place to usually start your graph. So I did that. Then I'm going to hit Zoom 6, which will give me a standard zooming window. And I see that. Now, again, remember from before, when you graph parametrics, you've got to be careful about where your windows are. So I'm going to look at this, and I'm going to change my window a little bit. It graphed only parts of those, so it looks like my Tmax is 6.2. I'm going to up that to like 15. And then my T-step is going to, and then my T-step was a little bit too big. So you want to shrink down your T-step, and trust me on this one, you want to do like 0.05. And then it'll go slow enough, and it looks like those are going to collide way off to the right. So I'm going to increase my Tmax to 15. And then if you hit graph, you will see that they look like they collide toward the beginning, and then their paths cross toward the end. So algebraically, though, we need to figure out how to do this. So in order to do that, if two things collide or their paths cross, that means the x's of the paths are equal, and then the y's of the paths are equal. Except these can't all be the same t. One of these t's belongs to ghost 1, so we're going to call that t1, and the other t belongs to ghost 2, so we're going to make that t2. So if I want to solve this system, it'll give me the t1 and the t2 where they cross and collide. And so I'm just going to solve this system. These t2s, if I were to add these together, are going to cancel out. So I'm going to do the elimination method of solving the system. And I'll get negative t squared plus 6t1 equals 5. And let's see, I'm going to solve that. So 0 equals t1 squared minus 6t plus 5, which means t1 minus 5, t1 minus 1 equals 0, which means t1 equals 5 and 1. So at time 1 and 5 for the first ghost, that's where their paths either collide or intersect. Now we need to find t2, and we have 2t1 equals t2 plus 1. I'm going to substitute, so 2 times 5 equals t2 plus 1, so t2 equals 9. And 2 times 1 equals t2 plus 1, so t2 equals 1. So what that tells me is, since t2 equals 1 and t1 equals 1, they collide at 1 second, and their paths cross later on. This one hit that point at 5, that one hit the point at 9. And if I want to know where they collided and intersected, we just plug these values into the functions. So if I do x1 of 5, I'm going to get 10, and y1 of 5 is going to give me negative 5. So at the point 10, negative 5, that's where their paths cross. And then when t1 equals 1, I'm running out of room here, x1 of 1 is 2, and y1 of 1 is 3, so they collide at point 2, 3. So that's just a bunch of stuff that you can do with parametrics as far as graphs go. And then the last thing we need to talk about in this video is derivatives. So when we talk about derivatives of parametrics, really you just need to memorize the stuff that's in this box. I'm going to explain it, but really you just need to memorize it and move on. All right. So if you want to find dy dx, notice it says dy dx. That really means you need to find dy dt and dx dt because x and y are defined independently. So if you want to know the slope of a curve or anything else that will require the use of dy dx, you divide dy dt by dx dt. If you need to find the second derivative, it's a little bit trickier. If you need the second derivative, you take the derivative with respect to t of dy dx and then divide by dx dt. There's a long reason for that I'm not going to go through here, but basically it's just a way to make sure that you've taken 2 derivatives of y and 2 derivatives of x. And the way to guarantee that is by doing this strange fraction. So the second derivative is really the derivative of the first derivative divided by dx dt. So let me just show you how it works because it's actually not that hard. So it says find dy dx and that for the ghosts. So let me quick bring the ghosts down here. I need to bring this. Oh, and there's a line in it. That's silly. Let's try that again. That should be better. Oh. See, it doesn't even like me. There we go. Alright, so here's my ghosts, alright? If I want to find dy dx for, say, ghost number 1, we'll do that all in green. So for ghost number 1, if I want dy dx is dy dt divided by dx dt. Well, where do those t's come from? Oh yeah, x is defined in terms of t, and so is y. So if you want ghost number 1, you take the derivative of x and y with respect to t and divide it. So this is 4 minus 2t, there's dy dt. dx dt is just 2, so dy dx is 2 minus t. If you want the second derivative, d2y over dx squared, you take the derivative of dy dx and then divide it by dx dt. Okay, it's just a rule, just do it. So you take the derivative of dy dx, so the derivative of 2 minus t, which is negative 1, and then you divide it by dx dt, which was 2, and your second derivative is negative 1/2. That's it. It's really not that complicated. So let's do it for ghost number 2. So if I have ghost number 2, dy dx is going to be y prime of t. Come on, computer. Y prime of t divided by x prime of t. Feel free to use that notation. Y prime of t is negative 1. X prime of t is 1. So dy dx is negative 1. And if I want the second derivative, I take d dt of dy dx and divide by dx dt. Well, the derivative of negative 1 is 0, divided by dx dt, which was 1. 0 is your second derivative. All right, that's it. Enjoy the rest of your evening. We need a joke. What kind of building is the tallest? A library, because it has the most stories. I can't.